Kw, the water constant. Water is a weak electrolyte. That means water is a molecule, H2O, but it can undergo self-ionize to a small extent. But what do I mean by that? Look at the molecule, H2O. Can a H2O combine with a H2O form into a OH minus and H3O like in this picture? This situation this called self-ionization. Does it happen? Yes, but to a very small extent. How small is this small extent happen in molecule? Very, very small. Now let's see. So how many would this water self-ionize take place? In 1 liter of water, you will find the H plus ion concentration on 1.0 to the 10 to the minus 7 mole per liter. That means you have about 0.00000001 mole per liter. That means very, 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 very little. And how much will be the OH? Same concentration too. Very, 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 very little. So basically 1 ion in 55 billion particles of a water molecule you will find. And so you will find that's the relationship. The H plus concentration and the OH minus concentration are equal. The second relationship is the concentration, they both equal to the same number, 1 times 10 to the power of minus 7 mole per liter. And if you juggle this figure, you can get a Kw. If you put the K of this times the OH together, if you time these two numbers together, you give you even a more smaller number, 1 times 10 to the power of minus 14 mole per liter. That means equal to, you will have, in a pure of water, you will have 0.000000000000001 mole per liter. And then, come on, that's ridiculous. What are you talking? Does this serve any purpose? Basically, you can say 1 tiny dust in the ocean. Does it serve any purpose of this crazy equation? Yes, it does serve a purpose. Now we see. Imagine if you're in a pure water. Here, the equation we're quoting. Now let's see the scenario. Imagine if you put acid into water. And now what happened to this equation? And you know in this equation, the number have no change and the H is increasing. The H plus ion concentration is increasing. That's not surprise. You put more H plus ion into the pure water. My question is, how much will be the OH minus? 2 questions I want to ask. Would this OH minus be increase or decrease or stay the same? The answer is when H plus ion increase, the OH minus will decrease. Now I ask the second question. How much would it be decreased by? How much, to what extent? So in case if this increased 10, this H plus I increased 10 times, how much would this be decreased by? It will be decreased by guiding by this number. The OH minus will decrease by the guiding by this number. So if this number, you say, oh, this 10 to the minus 14 is too hard. Let's make it 15. Okay, this number will change. So this number of this number, this K number, would determine whenever how much you increase and to what degree you will be decreased by. If you know this, know the H plus, by using this equation, you will find out how much OH minus. To what extent would it be decreased? And that's the use of this equation, this K constant. Now, if I put the same scenario, in this pure water, I put in some base. This equation, the OH minus will of course be increased now. Then, how much would be the H plus I now? It will be decreased, but decreased by how much? It will be decreased by the guiding of this number. So this number determines how much, to what extent, when one increase, the other will be decreased by. And now, so this number is not a random number. This number, when you have one been changed, the other, when say the H plus been increased, you also, by using this number, you will find out the OH minus concentration, or vice versa. Now let's look at example. In this situation, this person put in some acid into the solution, HCl. How much HCl that he put in? 1 times 10 to the minus 2 mole per liter HCl. The question is, now what will be the concentration? HCl, they say they put in that much. And remember, they fully ionized, so the Cl minus and the H plus ion will be the same. Now the question is, how much will be the OH minus now? I'm going to use this equation to find out. Now, H concentration we know, OH we don't know, and we know the constant number. So, and we flick this across, become divided, and use calculator give you OH. So this is the concentration of the OH minus now. So this K constant number of this giant minus 14, when one number change, when the H concentration increase, you will, by using this number, you can find out the OH minus, or the vice versa.